Hello and welcome to part 2 of section 3.7, which deals with the distributive property. If you are watching this video, that means you did the first part of 3.7 and you understood what to do when there's a number out front. I'm going to take it one step further. This is our last section in chapter 3. We'll get to a review eventually, but we're going to continue with the distributive property. And here's the work that I'm hoping you can do once this lesson is done. So if we were to continue to the next page, and you have this page in your book, this is part 2, it says continued here, 3.7. So maybe pause the video and make sure that page is open in your book so you can copy out. We will now look at expressions with a coefficient or a number and a variable or a letter out front of the brackets. So up until now, after watching the first part to 3.7, I think that you can solve something like this. 3 times 2 is 6 of these x's. 3 times 4 is 12. You're positive, you stay positive, you stay negative, and you've expanded out the brackets. But we're now going to look at expressions like this or expressions like this. And notice everything the same, except instead of a 3, it's now a 3x. Or instead of a 3x, it's now a 3x squared. Do you see the variable now out front? This is the new part, okay? We know how to do this. We know how to take care of the 3 in each of these. We just need to know how to take care of the letter. So there are just 2 steps that involve a few different parts. But pause the video, you can copy this out, and then I'll go through it with you, and we'll do some examples. But the first thing you're going to do is expand out the brackets by multiplying the coefficients or the constants together. You already know how to do this. 3 times 2 is 6, 3 times 4 is 12. That's what this is. The new part is using your exponent rules to get your new exponent. So when you have one like this or like this, we go 3 times 2 is 6, but x times x is x squared. X to the power of 1 times x to the power of 1. This is an exponent rule. We add the powers, we get x to the power of 2. So we get 6x squared, 12x. Here we get 6x cubed, 3 of them, x squared times x to the power of 1. We add them, we get x to the power of 3, x cubed. And then we get 12x squared. Then we use our rules to find the sign. If it's a positive out front, everything stays the same. If it's a negative out front, everything changes. And then just add or subtract your like terms. So copy this out. And the only new part today's lesson is applying our exponent rules, and in particular, the multiplication rule of adding our powers. So once you get this copied out, let's go through a couple examples here. And let's look at the first one. We've already learned how to do this one. This was from the first part. But just to get us going, again, 3 times 2 is 6 of these x's, and 3 times 4 is 12. You're a positive, you stay positive, and you stay positive. We're done. But on the next one, here's the difference. This is equal to 3 times 2 is 6. But x times x is x, and I've got to use my exponent key here, to the power of 2. Now I go and I move along. 3 times 4 is 12. I'm going to bring this back down. So it's 12. And x times no other x's here is just an x. Do you see how this term right here got 1x bigger because of this? And this 12 got 1x bigger. Now all we have to do is put the signs, and since this is a positive, we know you stay and you stay. And there's your answer. Let's take a look at this next one. I'm going to start with an equal sign. Forget about this negative, forget about this sign. It's just 4 times 3 is 12. But y times y is y to the exponent 2. I move to the next one. 4 times 2 is 8. 1y here, no y's here, means 1 total. Now, for the first time, what do you notice is out front? This is a negative. So this positive term goes to a negative. This negative term goes to a positive, and you're done. The expansion of negative 4y times 3y minus 2 is negative 12y squared plus 8y. Try this one on your own, pause the video, and then come back and see if you got it right. All right, so hopefully you've tried it. Let's go through this. Forget the negative, forget the negative, forget the positive. It's just 3 times 3, that's 9. W times W is W to the power of 2. That's the exponent rule. W to the 1 times W to the 1. Then we move to the next one. 3 times 5 is 15. W times nothing is a W. You're a negative, so you change to positive. See the negative here? Becomes a positive, and this positive becomes a negative. And we're done. Next one, we have 2 to expand out here. So let's do both of these. Equals 3 times 2 is 6. X times X is X to the power of 2. 3 times 1 is 3, and X times nothing is X. You're a positive, so you stay negative, and you stay positive. That first bracket is now expanded out. We continue, and we go 4 times 2 is 8. X times X is X squared. I'm just going to cut and paste this, or copy and paste it, because I know it's an X squared term. And then I move along. 4 times 2 is 8. I knew I was going to do that. So is 8, 4 times 2, and X times nothing is an X. Now, out front is a negative. So you change, and you change. And now we've expanded out, but the one last step we have to do in this one is you see you collect your like terms, you add or subtract. So what we have to do is say, all right, let's move our like terms. Here's my first term. I'm just going to copy it, and I'm going to paste it. There it is. You're not an X squared, but you are. Copy, paste. You're not you're the next one in line, so copy and paste. And copy and paste. And now let's just simplify this. Negative 6 of these X squareds, take away 8 more. Well, that leaves us with negative 14 of these X squareds. Copy, paste. And 3 plus 8 is 11 of these X's. And we're done. Last example. Try this one on your own, see what you can come up with here. Pause the video and then you can come back. All right, so now that you're back, let's go through this one. 3 times 1 is just 3, but X times an X squared is an X to the power of 3. Do you see that? This is an X times an X squared. 1 here, 2 here, total of 3. We move to the next term. 3 times 2 is 6, and X times nothing is an X. You're a positive, you stay, and you stay. So there's the first one. We go to our next bracket. 4 times 5 is 20 of these X cubes. 4 times 5 is 20. X squared times X is X to the power of 3. We move along, and we say 4 times 3 is 12. X squared times nothing is an X to the power of 2. It's an X squared. Now, you're a negative, so you you change to a negative, and you change to a negative also. Just bring that back down. There it is. You see how both these positive terms changed? Now, the hard part's done. We just got to reorder them here. So equals, we'll start with the 3x cubed. There's my first term. Copy and paste. That stays. Here's my other x cubed term. Copy and paste. There are no other x cubes. So I could put this term next, the x term, but I'm just going to go kind of descending degree, it's called. I'm just going to take the next lowest exponent from a 3 down to a 2, and then I'll put this one on the end. And now you got your 3s to your 2s to your 1s. It's like a more of a logical order. Would it be wrong if you have the negative 6x first? No, but like I talked about in class, it's just not as precise. So 3 take away 20 is negative 17 of these x cubes. Copy and paste, there they are. I'm now going to go with minus 12x squared and minus 6 because those are unlike terms. We cannot combine them. They just follow down and we are actually done. 2x cubes can be combined. These cannot. They're unlike terms. So we are done. So the only new thing today is we have this x. The part 2 is we have this x or this x squared or this y, this w. We have a letter out front. And just know, use your exponent rules and count how many total. 1 here, 2 here, so we have a total of 3. 2 here, 1 here, we have a total of 3. All right. So you have some work to do. Here it is. Don't worry about this stuff here. Just delete that. And I'll delete this. We don't need that. But here is your work on this part 2, which has variables involved. Hopefully you understood this. And please reach out to me if, in fact, you're having any trouble.